Hi everybody. Today we'll talk about lecture C1, discrete event system motivations. I'm recording from a place where there's an industrial pump that will kick on periodically. It's actually relatively infrequent, but if you happen to hear some sort of strange hissing in the background, that's what's going on there. So hopefully that doesn't happen very often. But anyway, so let's move on. Quick, general announcements. The I've mentioned there's an arena competition that you can use as part of your final project, or as your final project, but there are other competitions as well. So, for example, the FlexSim also has a competition, which is also co-sponsored by IISE. And in the FlexSim case, you can actually have teams of up to 4 students, so you don't have to worry too much about the 3-student issue, and you can actually include up to 2 graduate students. Then both of them have a faculty advisor that has to sort of sign off on it, which doesn't necessarily have to be me. The difference in the flavor of the FlexSim competition is that it takes the shape of a real-world healthcare situational case study, and so the conference associated with it will be a healthcare systems conference, and so that may be of interest to some of you who are interested in these kind of healthcare applications of these industrial engineering methods. And of course, it uses FlexSim. FlexSim is another discrete event system simulation tool, very similar to Arena in some cases, but also kind of different. Similar awards, similar setup. Bonnie Cameron is also the organizer there, so if you have any interest in that, you should contact her with questions. Take a look at the link there, and the actual entry form is due usually a couple days before the end of September, so take a look at it soon. There are other competitions, so if you look out there, the Simio annual competition. Simio is sort of a language that was, when the guy who created Arena, when he left that company, Rockwell Automation, he started a new company and rebuilt a discrete event system simulation software package called Simio. And so Simio is sort of thought of as the kind of like sister or even offspring or something of Arena. So it has, again, a lot of similarities but some differences. I'm also willing to consider those for your final project, so just stuff to consider. All right, so when I say from last time, I mean back at the end of the B unit, we talked about using spreadsheets as simulation tools, building up to using programs like Arena, FlexSim, Simio. And so I mentioned that spreadsheets are this sort of interesting case of they're actually something we would technically call functional programming or cell-oriented data flow programming, where we're not actually modeling steps of a calculation. We're actually just modeling relationships. And so we model relationships between cells, and we don't actually care how things are done. The consequence of that, though, is that we don't really view a spreadsheet as having state. When we write a computer program, we usually write them in steps. We think of, well, what's the state of the program at a current step? If after that step, it will change the state of a program. And so the state of the program is always moving throughout these steps, but we don't have steps in a spreadsheet. But we know that discrete event system simulations are all about state changing. We have state variables. Because they have no state, then how do we manage to simulate something with state in a framework that does not have state? So we use this MM1 example. So this is Kendall's notations, MM1. M basically means it's a memoryless or Markovian process generating arrivals. The other M means that it's a memoryless or Markovian process generating service times. And the 1 means there's one server. So customers arrive at a particular rate. Those customers, the one that's at the head of the queue, will receive service and will be in there for a particular time. And while that customer is in there in time, any new customer arrivals will have to wait in the queue. And so that's your standard MM1 single server queue. So how do we simulate that? I'll just go through this very quickly because this is just review, but you can basically set up a spreadsheet that has all of the inter-arrival times, which are given. You can think of these as random numbers that were drawn from an exponential distribution, and all the service times that were given. You can also think of as basically just a bunch of numbers drawn from an exponential distribution. We start the clock at the first arrival, so the arrival time of the first customer is 0. And so we also know the first customer arrives and there's no one to wait on, so the first customer goes directly into service, and so its service time begins at 0. And given that, we can calculate when the service time ends, and it's just when it begins plus the first service time. So we kind of get all of this stuff for free about the first customer, and then we need to set up the formulas in the cells to get everything else. Like, so how long did customer one wait in the queue? How long did she spend the whole time? Was there any idle time of the server? Because in this case, the server immediately handled the customer. There's no idle time here. And so given that we have all this info about the previous row, then how can we generate the second row about customer 2? And so we said that, well, arrival times are easy. We just take the previous arrival time, add the next inter-arrival time, and we end up getting the next arrival time. So 5 plus 5 is 10, 10 plus 4 is 14, 14 plus 2 is 16, and so on. We can write that down here as saying the formula for this column is going to be the cell in the previous arrival time, so 10 in this case, plus the current inter-arrival time. So you go up for the previous and over for the current, and that's where you get 10 plus 4 is equal to 14. So you could think of what the Excel formula would need to be in order to make that happen. You could do the same thing with the time service time begins, where here it gets a little more complicated, but not too bad, where we're saying, well, when does this service time begin? The service time is for customer 2 will begin either immediately when customer 2 arrives or when customer 1 ends the service. And you just look for the maximum of those. And so that's kind of the later of the two. It's like whichever happens later, customer 2 arrives or customer 1 finishes service. And so in this case, it's when customer 2 arrives. And so you can implement a maximum inside Excel and do that same thing. And you can fill all that down. The waiting time, this is a simple thing. It's just, you subtract for every customer, when did they begin service? That's this column. And when did they arrive? That's this column. So you subtract the two of those and you're done. When they end, that's just when did they begin service? That's this column. Plus, how long did it take them to receive, or how long was their service? And that's this column. You sum those together and you get the time that the service ends. And then with all that together, you can then combine that and say, well, what's the response time for this customer? Well, the typical way we define response time, just to be easy, is to take the time the service ends minus the time the customer arrives. 7 minus 5 is 2, or down here, 21 minus 16 is 5. Now, we could have done other things, like we could have said, well, let's just add up everything the customer had to go through. Well, the customer, in this case, well, she had to wait 2 minutes, and her service was 3 minutes long. Well, 2 plus 3, that's another, that hits 5. So I could have added this and this. So for an MM1, that's an easy thing to do. You always know for an MM1, a customer is always going to spend the time she waits and the time she's serviced, and so those two add together are easy, and that gives you the response time. But if we had a much more complicated system, it might be difficult to figure out everything that the customer did while in this complicated system, and it's just easier to take the arrival time that they were stamped with, remember that's an attribute, and subtract the time that we know that they ended. So we subtract 16 from 21 and we get that customer time there, and we're pretty confident we've accounted for everything. And then the idle time of the server, like I said, there's no idle time for the first step, but then this one here, you basically say, well, when did service begin? And when was the end of the previous service? And if there's a gap in between those, then the server was idle in between. So this service ended at 7. So that's when the previous service ended at 2. The next service started at 5. So 5 minus 2 means that in between things, the server got 3 minutes of idle time just sitting around waiting. Down here, same thing. The previous service ended at 34, the next one began at 39, so between 34 and 39, the server was doing nothing. So she was idle, and that's what that 5 is, 39 minus 34. All right, so we said that we can take things like from that first homework that you did, homework B1, and so you could do a hand simulation this way, or you could do exactly what I was just talking about here. In your hand simulation, we simulate every time. So time gets spread out this way, but in the spreadsheet, we actually simulate every customer, and so time is almost spread out this way. So customers actually refer to 3 different times: the arrival time, the service begin time, and the service end time. So for every customer, we have these 3 times, and now we can end up still getting all of the same information out, but the way we simulate it is not this kind of state-based approach up here, where we're actually going through the state of the system, sort of emulating the real system as it goes, versus down here where we're just representing relationships that are always true during the system. And so in one of the previous lectures, in lecture B2, we talked about how I can say, well, if I want to figure out things from this, I can from this spreadsheet, from this list, I can also find them in this spreadsheet. So here I know that customer 3 departed at time 13. Here, customer 3 departed at time 13, so they match. So you can do those same games, and so you should be familiar with that by now, and so you can look back at some previous lectures, because I want to move forward here, but I'm just sort of recapping that at least it's possible to get all the info from the top box out of the bottom box and vice versa. All right, so normally I'd ask for questions here and maybe give you an attendance exercise, but since we're doing this as an online lecture, then I think I'd like you guys to go and take a look at the questions that are on Canvas.